Good afternoon, everyone. Happy Thursday, and welcome to the M Word episode 10. We made it to double digits. Hooray! One of those things, let's start these YouTube lives and see how we get on. Thought we might just do 2 or 3, but we're here after 10. Let's hope we're here after another 100. That'd be pretty good. But waffling already. That's a common theme in these sessions, but I'll get back to it. Welcome to the M Word episode 10. My name's Robin, and I'm here for the next half an hour to have some coffee, get away from the desk for half an hour, and talk about something technology related. So welcome back to all of our followers. If you're not already a follower, please give us a like, give us a subscribe, follow us on social media and what have you, and give us some comments as to what you would like to see in these sessions moving forwards. If you take a look at our YouTube channel, you'll see a load of hopefully interesting and helpful videos on how-tos, tips and tricks, new features. And really this session is a booster to that, aimed as a warts and all, off-the-cuff session to talk about Autodesk technology, design, workflows, and just try and give you something that's going to be useful. And today, I want to focus on iLogic and parametric modeling inside of Autodesk Inventor. iLogic is something that, sadly, being a geek, excites me. I think automation inside of Inventor is really neat and actually quite easy to achieve. Also, iLogic is fun. What's not fun about coding? A lot of things, actually, to be honest with you, but it's really useful. It allows you to do a lot of mundane tasks automatically, and it can actually save you a lot of time. So what I want to do today is something similar to one of our existing videos that exists on YouTube. So again, go and check it out if you haven't seen it already, but it's quite an old one that takes you through some how to get started in iLogic kind of videos from scratch. And I really want to treat the next 25 minutes or so as that kind of video, or that style of video, whereby we model something up really simply with some simple parametrics, and really explain how you can start using some very simple iLogic code to drive some automation. Maybe we'll just do 1 or 2 very simple examples. And if you want to see more, then get in touch and we can give you some more. But without further ado, I'm just going to check I am going into a small camera today. There we go. Good. Thank you very much. And hit the screen share as well so that we can see my screen. Perfect. So using 2023, I don't think anything I'm going to show you today can't be used in any version of Inventor back several years, to be honest. iLogic's been around in the interface for at least 12 to 15 years, maybe not quite 15, certainly 12, 13 years it's been in there. Maybe anyone knows better, drop us a comment, let us know, but it's been in there a long time. And what iLogic is it's an automation interface inside of Inventor where you can access Visual Basic coding to more of a better point, but it ties into the Inventor workflow really nicely. So what we're going to do is just start with a completely clean slate. You know how I like to make these sessions off the cuff, no prep, and just do it as it is, really, just to show you. And in some cases that is demo ghost and all, but just to show you how we can get started on these things. And hopefully that helps you guys in your own endeavors and helps you show you how to do things the right way. So we're going to jump into the part environment. And the first thing I'm going to do is just model a really simple component. And we're just going to use a box just because everyone can model a box. It's simple, but it's something that's easily scalable both via some parametrics and then via some rules as well. So let's go and start a simple 2D sketch. I'm going to use the top plane here, spin this around to help my OCD, and we'll place a 2-point center rectangle. Please make that the default selection. That would be lovely rather than the standard 2-point center rectangle, and let's constrain that to the center point. Now the first thing I want to do here, because I'm going to create something that's parametric that I can then drive, whenever you create a dimension in Inventor, it will name that dimension with a generic name. So the first dimension you place will always be D1. The second dimension you place will always be D2, so on and so forth. And that's okay if you've only got a handful of dimensions, but if you've got typically any logical design, you're going to have tens, if not hundreds, if not thousands of dimensions in there. So to give them a more specific name, whether that name is something obvious to everyone like length or something obvious only to a few individual people like banana, it doesn't matter. If you've given it a name and you can identify it and you know what that name does and what it drives, then that's great, because then it's much easier to understand and reference that in code later on. So I'm going to show you two ways in which you can do this. So before I've actually placed this down, Inventor will allow you to place a dimension. So I'm going to give my box a width of 500. But rather than just typing in 500, I'm going to type in the word width and then equals. That tells Inventor that I'm going to name that dimension width. I then type in the dimension that I want, which is 500. The text goes black to say that it's understood what I'm doing, and I'm just going to press enter. Okay. You can do that same functionality if you're placing a normal dimension, so D on the keyboard or dimension tool. To place a dimension to the side, I can also do the same thing here. So I could type in depth equals 250, for example, or depth equals length divided by 2. Okay. Again, I'm going to do the same thing here. So I'm going to say this is depth equals 250. Okay. Keep it really straightforward for now. As you know, parametrics works in Inventor from the get-go. So if I didn't want 250 and I wanted some intelligence in there, I could say that it equals the width divided by 2. And you can already see that that intelligence is being picked up. The name of that component is already being picked up. But actually, in this case, I do want it to be set at 250 for now. We're going to finish the sketch, right-click Finish, and I'm just going to extrude this up. On the extrusion, we have another dimension. Whether you're typing it in over here or whether you are typing it in over here, this is another dimension. So this will be D3 in the purpose of what I'm doing. D1 was length, D2 was width, D3 will be this one. To show you the third way of controlling the names of these dimensions, which for a lot of you out there that are already using Inventor, this will actually be quite beneficial because you will have models with stuff in it already. So I'm just going to pull this up by, I don't know, 50 mil, something like that for the purpose of this for now. So let's just pull this up 50 millimeters, no taper angle or anything like that, and just hit OK. If we then visit the parameters, either by using the quick access toolbar at the top or coming to manage and then into parameters, either. When you're in there, you'll see our dimensions. Okay, so there is our D1, there is our D2, it was D2. And then you've got these for the extrusions. One will be the height of the extrusion. The other one's actually the taper angle, which is always there. It's not specified in this case. So let's call this height, and I am actually going to rename this one taper as well. Okay. That's the other way that we can define these parameter names in here. And as anyone that's been using Inventor or any parametric modeler a while will know, by having those dimensions and information in here, I can start saying that this is now a square rather than a rectangle. I can up this one to 750 and say that the depth is always the length divided by 3. Helps if I have a length. I don't have a length. Can't type in length if I don't have a length. Width, there we go. Width divided by 3. I told you this would be warts and all. Width divided by 3, and it will work it out for you. That's standard parametrics. There's nothing overly new or remotely different about that. That's just how these applications work nowadays. But what we can do is tap into those parameters and start to use those to greater effect. And there's a few different ways that we can do this. Actually, sometimes we might have a really simple product that we just want to control quickly and easily using a simple form. So I've got a simple box here, and that box just has a width and a depth, and a height and a taper angle. Okay. Now, if I want to get into iLogic, I can do one of two things. In the more modern versions of Inventor, I can press the Show Tabs up here and choose my iLogic interface. That can be pulled and snapped to another part of the screen if you want to. We can also, if we don't want to use that way, we can go to View, and we can go to User Interface, and we can click on iLogic down here as well. It does exactly the same thing, but it's a different method of turning that functionality on. And the latter there would be used in the older versions of Inventor. And we have two elements in here that's kind of split. We have internal elements that exist only within this file, and then we have external elements which exist on my local disk or a network drive that can be shared by several files or several resources. And those are split with rules, something that's written to do something, or a form, something that's used to drive something. And the forms, what we're going to start with today, are so easy to use. I don't know why more people don't use this functionality, because I can just go to Forms here, right-click and say that I want to add a form. In that form, we get a really simple to use form editor pop-up. A little bit slow for some reason, but that form will pop up as an empty form over here on the right-hand side. And then on the left, I get my form editor, which is a real simple to use interface. And that interface will essentially on the right-hand side have an area whereby we build our form with some fields and data here and the properties relating to them underneath. And on the left-hand side over here, we've got elements that we can tap into. So we can tap into parameters that we've added, or iProperties that exist within the file, or even rules that exist within the file. So what I'm going to do, I could add pictures to the top of this if I want to, or spaces. We're not going to bother with that. We're simply going to say that I want to have the width, drag and drop onto the form, the depth, drag and drop onto the form, and the height and the taper. That'll give me these text boxes over here for typing. I can give this a name. Let's call it Rob's Magnificent iLogic Form. Seems like an appropriate name, something so intelligent as this. And then we'll change some of these configurations. At the moment, they're text boxes. I want these to be sliders just to make it a bit more visual for you today. So the width here, I'm going to select it, come down to the options, and just scroll down. I can change the text, the size, and stuff like that. I just want the behavior here to be a slider rather than a typing. And then that slider has properties such as a minimum, a maximum, and an increment. So I could say the minimum size I want my box to be is 50. The maximum size I want my box to be is 5,000, and I want the increments to be in steps of 25. Okay. I'm going to do the same thing for the depth. So change the depth here to a slider. So rather than a text box, you are a slider. And again, I want you to be in the slider properties, minimum value here, let's say 100 for the depth is the minimum. I want the maximum to be 1,000, and I want the step size to be a bit smaller at 10. I'm going to leave the other two as a type-in value and press OK. And I'm just going to go and save this because I know what will happen otherwise. I'm just going to save it away in there. And once that's saved, we get this form appear. Okay, so I can open up that form. Gives me a really easy form. Again, you can add images and all sorts to this if you want to. This is just a simple variation. I have a slider here whereby I can literally pull that slider, bigger or smaller, and it will change the width. I can then change the depth, like so, and I can basically now configure any element. Yes, I can still type in if I want to, so I can be 1,000 by 725 or 123, but I can also control that here with these sliders. We can do a type in for the height, so make the height 500 and make the taper angle 2.5 degrees, okay, or even 50 degrees, or whatever it is that you want it to be. So all of that functionality is just controlling, for more of a better word, what I can do through the parameters dialog box. But it's customizable. It's allowing me to drive it in the way that I want to, which is great. Let's just drop that back to 500 by 250, no taper angle, and maybe 100 mil on the height. So those forms are really straightforward. But the other thing that we can do with those forms is add buttons to them to do extra stuff. And that's where the rules come in. So a rule, within reason, don't get me wrong, you can do a lot with them, but within reason, they can do anything that you can do in Inventor with your mouse and your keyboard. So they can place components in assembly, they can create drawings for you automatically, dimension things automatically. Within reason, you name it, it can do it with a certain bit of code. Now there is a crossover between what's too complicated and what's right to focus on, certainly for the generic user. But you can go full spectrum and do full configurator workflows with iLogic without having to buy any additional add-ins or anything like that, which is really good from a positioning perspective. Now, what I want to do is create my first simple rule in here, okay? So let's go to my rules. And again, this is completely off the cuff. I'm just trying to think in my head of things that we can start to explain the power of what this can do. And I want to give a couple of examples. So firstly, I'm going to create a rule. So right click, add a rule. These are all internal. So remember I said you've got internal and external. Again, external, if you're using a rule in several documents, don't just save it in your template, have an external rule so it can live and be edited and controlled outside of the Inventor environment. But if it's only ever going to be used in here, just use it internally. It will make it run a little bit more, a little bit nicer for you. So let's call this my first rule. And what we're going to do with that first rule is add a really simple bit of VB code with an if statement and maybe a couple of message boxes. This is positioned as easy to learn and easy to access. Because of that, you've got a really nice interface that isn't just a coding interface. So up here, you've got your part or your assembly and all of its contents, including your parameters, including your features and even your sketches. Each one of those can be right-clicked and captured to get any information about that particular object, okay, which is great. You can also use options at the top. I highly recommend anyone doing anything with iLogic, unless you need it to, turn on don't run automatically. Especially if you're running several different rules, if you leave that turned on even one or two of your rules, they might trigger over and over again without you wanting them to, which might make your entire iLogic process look much slower than it actually would be. So I recommend you turn off don't run automatically and just control it with some separate triggers. More on that later if you want to discuss that in more detail, or indeed check out the other videos that we've got on the site or the other information we post on social media to be able to identify different tutorials we've got for that area. Alongside that, we've got some wizards, which we'll use in a second to create some message boxes, and some snippets on the side to get it to be able to, to tell us how we update the Inventor document on demand. Just double click the snippet and it puts it in there. So you've got loads of ability to start using this as a brand new user. But what I want to do is have a really simple process to say, how big is this box, and based on if it's under 500 or over 500 millimeters, go and do something. So step one, I need an if statement. So first thing to do is always comment your code. Little quote mark at the start of the line will comment the code, and I'm just going to put sample code created for the M word, if I can spell, on the 28th of April. It's always good to do that. When was the code created, who created it, and what was the purpose of the code? It just means that you've got a log there. It's a good coding best practice. And from there, if you know how to code, just type it in, happy days. If you don't, use the tools that are available to you. So I want an if, then, end if, or an if, then, else. We've got all of that ability up here, okay? So if you didn't know how to write an if statement, you could say, click this one, and change the orange my expression bit to suit the expression that you want to do, okay? If you know the code, you can just type it in by hand. So I want to say if the width, remember that's the parameter. Again, if you don't know what it was or can't remember, just go back to model parameters up here, find it and double click it, okay? So if the width is less than 500, or maybe let's say less than or equal to 500, then it's going to do something, okay? Automatically indents your code for you, which is lovely, apart from when it doesn't. As I said, iLogic is fun, but it's useful. If width is less than or equal to 500, then I want to show a message box. If you know how to write it, just write it. But in my case, it's an example where I can show you a wizard. Come to your wizard, go to message box wizard, and it gives you a wizard on your screen to be able to do that for you. So the title of this is going to be my first rule. The icon is going to be a information icon. The message is going to be the where are we? The width of the design is less than or equal to 500 millimeters. The buttons is going to be OK, and the default button naturally is going to be OK. You can preview it if you want to, but I'm just going to press OK, and it will place in the correct code for that there. Now, if you don't need to control all the message boxes and stuff like that, don't get waylaid or caught up in it. Just type MSG box equals and type in your message. But it gives you a wizard which will help. Anything else? So if it's if it's more than 501, then I'm going to copy exactly the same line here, come down a few, paste it, and say greater than. Okay. Save. Make sure you put an end if on the end. Always put an end if on the end. Hit save, and then I'm going to say close. Off the back of that, go back to your form, right click and edit your form, come to the left hand side, find the rules and drag and drop that rule that we've just created. Again, apologies why this is a little bit slow, not quite sure why. Go to your rules, drag and drop my first rule onto the form here. Maybe we're going to put a little empty space between the two just to space them out. And maybe we want that to say, give me a message on here. Hit OK, open up your form, press give me a message. The width of the design is less than or equal to 500. Brilliant. Come down there, give me a message. Fantastic. Go up there, give me a message. Fantastic. Works as you would expect. Really simple, doesn't really help you do anything, but a nice way to show you the different kind of code that you can start to add in here. It's a basic if statement that shows a message box. But because of that, we can start driving some interesting things. Just to try and get this all on one screen, because we're streaming and I'm quite limited to what I've got, I'm going to get rid of the niceties around that message box and just literally have a basic box on there, just so that you can see it all on the same screen, which might help you guys out if you're following along or copying on here. So let's just do that by just getting rid of the rest. And I'm just going to build this out a little bit. So I'm going to say if the width is less than 500, then I'm going to say if the width is greater than 100, then the width of the design is within allowed limits. Else, a message box that says maybe the width of the design is too small. And then we're going to set the width to the minimum allowed amount, which we're saying is 100. If it's greater than 500, it's maybe coming towards the maximum. So otherwise, else, we're going to say if the width is equal to 500, the width of the design is within allowed limits. Else if, let's say if it goes up to less than or equal to 1,000, it's still within allowed limits. But maybe if it goes outside of that completely, we're going to say it's too small and set the width to the largest value. which we're going to say is 1050, or 1000, sorry. And if, save, close, open our form, and on here we can drop this down, 400, 250, give me a message, it's within allowed limits. Try and go too small, and it's saying it's too small, and then it's going to update the design to the minimum allowed. Make it too big. Okay. So you can start to do things like design checking. You can check for is it too small, is it too big, so on and so forth. Let's just change that to too large, and let's add a update Inventor at the end using the snippet. There we go. So using this rule, we can now check whether a design is too big, too small, just right. Okay. Sometimes there's a little rule snippet that you have to add in there, actually, my mistake, which is called rule parameters output, just to make sure that that is updated into the model, like so. Lovely. But we can start to control some quite powerful stuff in here, which is really, really useful. If you then take that to the next step and say, okay, well, let's make this bigger. So let's just go up to a few hundred and say done. What I'm going to do is add a sketch on there. And then on that sketch, I'm going to do a simple slot. Let's just do a center point slot here in the middle. And let's say that that slot is going to be that big. The length of that slot center to center, I want to be the width of the product divided by 3. Okay. Press finish. Extrude that through as a cut. Just go through everything for the purpose of this. Brilliant. But then what I want to do is, under my rule, I'm going to change it so that if this gets too small, it's going to turn it off. And we're just going to use one of these ifs that we got up here. So if the width is greater than 100, then it's fine. We're going to say if the width is less than 200, then grab this one, right click, capture it, delete the bits that you don't need, make sure that you select them, press tab a couple of times to indent them, and we're just going to say turn it off. Because we've turned it off there, we need to make sure we turn it on where we need to turn it on, otherwise it will always be off. And what you can do is start controlling when something is shown, when something isn't shown. So theoretically, I missed an end if somewhere down here. So if we go under 200 but above 100, it should then turn that slot off. So we'll go down to 150, which is allowed. It will turn the slot off. If we go back above, it should turn the slot back on, apart from I've missed that bit because it's down the bottom. Apologies. If it's equals 500, if it's less than 1,000, it needs to turn that on. There we go. Save, close, run. Beautiful. So we can start to control when something's on, when something's off, how many occurrences in a pattern, when a pattern's on, if there's two different patterns, anything that you can do with your mouse. And it really starts to become quite powerful, which is great. If you tag this kind of functionality, which isn't doing much with regards to the actual automation of that, but if you start linking that with something that's a bit more complex, we can start to throw forms together that start to drive different shapes based on what you're doing. So it can be quite useful and quite powerful from that perspective. Now, what I really like about this iLogic workflow, just to finish this off, is how expandable or flexible it is with people that want to start doing a little bit more. And again, I don't want to do loads today, A, because I'm already kind of at time, but I'm going to just go over for a few more minutes. Because in here, I want to place in a few components. So I'm going to place in this Lego brick just here. And I'm going to place a couple of those in. Against that Lego brick, I'm also going to place in the part that we've just developed, just there. And then I'm also going to place in something else that I've got down here, like this box a couple of times, and this cylinder a couple of times. In here, I'm going to show you that in a rule, I can do more than just basic if statements and message boxes. So I can start tapping into raw API to program Inventor on how to do stuff. If you're new to it, go to the help drop down in Inventor, go to help, and go to programming API help. This has a really nice index and search facility in here that starts you to be able to understand the different calls that we can make to the application programming interface, API, to get it to do stuff. Okay? So if I create a simple rule in here, I'm going to tell this rule to cycle through all the components in this assembly and tell me their name. So I'm just going to have to do a few things. Firstly, add the comments I mentioned for best practice. Secondly, we need to define some variables now because we're doing a little bit more. So I'm going to define OApp as a name, as application, and I'm going to say equals this application. And there's loads of examples of this kind of stuff online on our forums, on our blogs, on our YouTube. So I define the application so that the rule knows I'm talking about Inventor if I use OApp. I then define this document, so let's just call it ODoc as assembly document equals this document. Again, this is very new to some of you because you don't understand coding or you're new to coding. This is standard terminology when it comes to programming. Just have a look at it up online, look at defining variables. We're just telling Inventor and the application interface that when I use the word ODoc or OApp, it's pointing at either this application or this document. And that allows us to drill down to something specific, such as the component occurrences. So let's dim OOX as component occurrences equals ODoc dot component definition dot occurrences. So whenever I use OOX, we're looking at the occurrences within the assembly document. Finally, we can say for each, so for every one, OOC as component occurrence, singular, rather than occurrences, multiple. So for each OOC as a component occurrence, if you don't want to write that, you can just come and dim that. I'm just being lazy. Alex would be turning in his seat down south. Dim OOC as component occurrence. There we go. For each OOC as, there we go. For each OOC in OOX, we're going to do something. Message box OOC.name. Next. Save. Component occurrence is not defined. Component. Helps if you spell it right. There we go. Hit save. OOC helps if you put the right terminology in there. There we go. Save. Don't rush code. It will break. Simple loop here. Hit save and run. And this is just going to give me a message box for everyone. So Lego brick 1, Lego brick 2, part 1, part 2, so on and so forth. It's just going to give me the names of all of those. But more importantly, I'm cycling through every single component within an assembly. I could easily cycle through all of them and build some dimensions. I could cycle through all of them and create a drawing for each one. I could cycle through all of them, check if they're sheet metal. If they are, update them, regenerate the flat pattern, and then export them out as DXF. The amount of abilities that you've got with iLogic is ridiculous. It's simple to use. If you want some help or some tips on how to get started, then please let us know. Again, we've got a lot of videos already out there on the social channels. Reach out, give us a comment, and start using it because it's really, really powerful. And with some simple code, you can automate some mundane tasks. But again, I can't stress enough, if you're using this, Rule number one, from my perspective, apart from the best practices of comment your code, go to the options and don't get your codes to trigger automatically. It could end up in making your code take longer than it does. Because when you've got it running automatically, any model update, it will run the code. And I mean any model update. So if this is part of a much bigger process, it's going to run this code once, twice, thrice, several times. So just keep that in mind and turn that off. Trigger it separately if you want to. And we've got two ways of triggering. Number one, manage event triggers, and we can trigger iLogic rules on any of these points for all documents or individual document types. Finally, you can have one rule that triggers several other should you want to. Again, reach out, give us a comment, get in touch, and we're more than happy to help you and point you in the right direction. We have a vast array of different examples to show you, from simple ones like this to fully fledged configurators for any number of different products. And on that note, 5 minutes over, because I like to talk about geeky stuff, and this is certainly geeky stuff. I hope you're still awake. I hope you're still alive. That's a fairly dull subject if you're not into coding, but hopefully useful. It's given you a few stepping stones. Next week, slight change to our YouTube live schedule next week, because we're not going to run it in the afternoon next week. We're going to run it at a slightly earlier time. Check our social channels and LinkedIn for the exact time, unless Ellie's catches up and she shouts 10 o'clock or 10:30 at me. But next week, what we're going to do is we have a manufacturing building information modeling event with myself and my friend Simon Brand. What we're going to be doing is talking about BIM for manufacturing and looking at the processes and the technology inside of Inventor, the links with Revit, the links with the Construction Cloud, in more of a detailed or specific event. So rather than boring you with my dulcet tones twice in one day, we'll do it once, but we'll broadcast it over our usual channels and YouTube Live. So please feel free to join us at 10 o'clock next week. I will be here. Simon will be here. My coffee's gone cold. What can I say? Star Wars Day next week. I always end these things with some really silly statement, but I'm going to say it. May the 4th be with you on Wednesday next week. Enjoy the weekend. It's my Fake Friday today. Nothing better than that. So on that note, I'm going to shut up and leave you to your days. Thank you very much for joining us. Take care, and I'll see you soon. Goodbye.